Good morning. Today is lessons 19 through 21 for Saxon Algebra 1 half. And here's what the deal is on these. This is fraction land. Fraction land, fraction land, fraction land. So what is the deal on this? If you have a fraction, let's say you have 4/9 times 5/7. Okay, basic rule is if it is a multiplication, that means times, it could be written like this normally. Sometimes you will write it like this. This means the same thing. So that's the first thing in fractions. A multiplication can be written several different ways. You're most familiar with things like 4/9 times 5/7, but we are not going to ever use this again. Ugly. The reason we're not going to use it is because it has an x in it, and we use x for algebra. So you'll see dots occasionally. Mostly you'll see parentheses. So what's the rule on multiplying fractions? Again, this is different than adding fractions. Multiplying fractions is top times top, which is 20, bottom times bottom, which is 63. And that's the answer. That's all there is to it. And I say top, bottom. In math, this is called the numerator. And this is called the denominator. Okay, because those take so long, I say top and bottom. But it's numerator and denominator. You multiply top times top, bottom times bottom, and you're done. Okay, that's different than something like this, where you have 4/9 plus 5/7. This is what will mess you up if you mess this up. This doesn't work. This, you're looking at, the denominator has to be the same for you to add them. You can't add different types of fractions. A 9 and a 7 are not the same. So in this case, you would say, okay, what goes into this that also goes into that? That's kind of how it's taught a lot of times. In algebra, we don't even look at it that way. We say, does this one look like this one? And the answer is no. But if I make this one 7 times 9, and I multiply top and bottom by 7, notice I am not changing the fraction, because 7/7 is just 1. Okay, and here, if I multiply top and bottom times 9, I'm not changing this fraction, because 9/9 is 1. But the denominators are now the same. So 7 times 4 is 28, and 5 times 9 is 45. So what I end up with is, and 7 times 9 is 63. So 28 plus 45 is going to be 55, 65, 73. 63s. Notice there's a totally different answer. That is multiplying. This is adding. They're always going to be a different answer, so don't mess them up. Multiplying, multiply top and bottom. Adding fractions, get a common denominator by simply making them look the same, but do what you need to do. Just if you're going to change the bottom one, you got to change the top one as well. Okay, and that's basically it. Now, there's a little bit of difference on this thing where we have something like here, 3/8 plus, or say times 2/3. Okay, in this case, when you're multiplying, you can do top times top, which is 6, and bottom times bottom, which is 24. And then you say, oh, this needs to be reduced. Well, that's equal to 1/4, because I know 6 times 4 is 24. Okay, that's fairly easy to do on a simple fraction. If it's a complex fraction, that's not as easy to do. What we're looking at is, remember, when you're multiplying fractions, it doesn't matter the order. When you multiply anything, it doesn't matter the order. For example, 3 times 2 is the same as 2 times 3. So you have to kind of get in your brain that you can swap these around. So if I notice here, I've got a couple things, and this is how we normally show this on our math paper. I know that 3/3, because if I just move this 3 over here, it would be 3/3. What's 3/3? Well, it's the same as 7/7 or 9/9. It's 1. So 3/3, I cross that out. And when I say that, you say we cancel them or we cross them out. What I'm doing is I am making them ones. instead. So 3 over 3 is the same as 1 over 1. So that's what I mean. And so that makes it fairly simple. And 8 is the same as 4 times 2, correct? Yes, it is. So, but 2 over 2 is 1. So I end up with 1 times 1 is 1, and 4 times 1 times 1 is 4. And so I can get the answer without having to multiply the whole thing out and then reduce. I can reduce it before I ever start. And we've talked about that before. And if you can factor those things into prime factors, you will always get the lowest fraction. So one more time. If I have a number like, I'm going to make one up, 16 over, let's say 72. I know that will reduce because they're both evens. So what I'm going to do, but I'm going to times that times 3 over 2. Okay, so here, when I'm multiplying them out, I can just multiply them out and try and figure it out. Or I can say, well, wait a minute, 16 is equal to 2 times 8. And then these 2's will cancel. Okay, 72 is equal to 3 times 24. And then, so these 3's will cancel. But wait a minute, 24 is equal to 8 times 3. So these 8's will cancel. And so when I'm all done, notice everything on the top is canceled. That what it means it's 1. And everything except for 3, that's just 1/3. So kind of cool, huh? So that much more complicated problem, just by canceling, becomes 1/3. So how I'm doing it here, and I'm also showing you a technique, which is, one more time, now I'm going to be specific on it. You've seen it twice, now I'm going to speak it. So let's say you have a problem here. I can make an adjustment, then rewrite the question, then make an adjustment, rewrite the question, and take up a lot of space. What I'm going to do is I'm going to notice an angle cross there. I'm going to make that 2 times 9. Why did I do that? Because I see a 9 on the bottom, and I know 18 is 2 times 9. So now I can cancel the 9's. I know that 30 is equal to 2 times 15. I make it that way because I know I have a 2. I can cancel. Now I'm looking at this and I'm saying, okay, there's a 4, that's 2 times 2. 15 is 3 times 5. Those are all the prime numbers. That's as big as you're going to go. They don't cancel each other. So I'm going to end up with 4/15. This is how you would show that, and also where you could, where you can also check your work to see, did you do it right? So I go back and I go, and you make a mistake, you go 18, that's 2 times 9. Well, if I wrote 3 times 9, I'd be able to see that. So that's a scoop there. And now, next on lesson 19 is this concept, which is a little weird. We call these things complex fractions. So I'm going to give you an example. If I say 5/7 over 4/5, okay, what that means, it means 5/7 divided by 4/5. When you see a fraction, it doesn't matter what the fraction is. I'm going to go up here, and let's say if I have 2 over 3, that means 2 divided by 3. So fraction is always the numerator divided by the denominator. I can write it 2 divided by 3 or 2 divided by 3. This is 5/7 divided by 4/5. So you always look at it as there's a middle one. It's usually bigger. Unless they're just all fractions, then you just pick the middle one. It's this divided by that. But we also know in fractions that we never divide. This is 5/7 times this one flipped over, or what's called the reciprocal, 5/4. And now we just do this like we would normally do it. And the answer is 5 times 5 is 25, and 7 times 4 is 28. You can't prime factor or cancel anything on this one. So if you see a fraction over a fraction, it just means the first fraction divided by the second fraction, or the first fraction times the reciprocal of the second fraction. And if you need to write it out, this way first, then this way, so you don't mess it up, feel free to do that. That's not a big deal. And that's your lesson for problem set number 19. Okay, so let's move on to problem set number 20. And problem number 20, or problem set number 20, is kind of going towards this idea of what they call least common multiple. Least common multiple. Okay, LCM. In practicality, it's not super important that you memorize LCM and it triggers something. What typically happens is that you just do problems that use the least common multiple. And so let's give you an example. If I give you three numbers, 24, 55, and 80, and I would say, what's the least common multiple? The reason you would do that is because you're looking for, trying to find the lowest fraction that you might deal with. Okay, so let's do it this way. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So 24 is going to be 2 times 2 times 2 times 3. Y'all with me on that? 2 times 2 times 2 times 3. 55 is 5 times 11. Okay, 55. And both of those are prime numbers, 5 times 11. Okay. 80 is going to be 8 times 10. 8 is 2 times 4, which is 2 times 2. 10 is 2 times 5. So we have 1, 2, 3, 4. So 80 is 2 times 2 times 2 times 2 times 5. Okay, so what we're looking for, if we want to find out what is the least common multiple of these things, that we're looking for the smallest number that is divisible by all of these. The least common multiple of this is going to be just, well, notice there are, let's start with 2's. There's 4 2's. 2 times 2 times 2 times 2. Okay, so that's how many 2's. What's the most of the number of 3's we have? Well, we only have 1 3. Most 5's is 1 5. And most 11's is 11. Okay, so what this means is this number, 2 times 2 times 2 times 2, times 3 times 5 times 11, that this number, whatever that is, I'm not going to multiply it all out, that these will go into it. If I were to say, okay, 24 times what? 24 times what would give me this number? Well, 24 is, well, I add another 2, add another, and no, 3. It's got 1, 2, 2, 1, 2, 3. Okay, so it's missing a 2. It's got a 3. It's missing a 5 and an 11. Okay, that would equal this number. On this one, 55 times, well, let's see, 1, 2, 3, 4, 4 2's. 1, 2, 3, 4 2's, and a 3. And then 5, 11, that would equal this number. This number, 80 times 1, 2, 3, 4, 1, 2, 3, 4, a 5, it's got a 3 and an 11. If I multiply this times 24, I'll get this number. If I multiply this times 55, I'll get this number. If I multiply this times 80, I'll get this number. Okay, and so if I want to figure out what I have to do to multiply each in, this is a way to say that. And that gives you the least common multiple. For right now, It's pretty much all you're asking for here that are tough. Okay, and let's do one more from your practice problems so you can kind of see how this works. We'll get to how we use it in a minute, but this lesson on lesson 20 doesn't really ask you to use it. It's just saying, can you do this little thing? So let's look at practice problem C. Okay, and this one says, okay, if I have an 18 and a 250, what's the least common multiple of all those? Well, okay, 18, that's equal to, I'm not going to write it with a tree, I'm going to say that's 2 times 9, and 9 is 3 times 3. 250 is 2 times 125. 125 is 5 times 25. 25 is 5 times 5. So I could do this with factor trees, or I could just say, here, notice that's 10 times 25, 250. So I'd say, okay, what's my least common multiple? Well, that's going to be a 2, 2 3s, and 3 5s. Okay, so that would be 18 times something is going to give me that, and something times 250 will give me that. So that's my least common multiple. What that number is I go ahead, and if I want to figure that out, I'll go ahead and figure it out. So that's 2 times 3 is 6, 6 times, and I would just multiply all those out, and I would get the number. Okay, another example, this is problem letter D, and I have 35, and I have 60, and I have 90. Okay, and I want to know the least common multiple. Well, I'm going to factor these. This 35 is 7 times 5. That's easy. 60 is 2 times 30. 30 is 2 times 15. 15 is 3 times 5. And 90 is 9, which is 3 times 3, times 10, which is 2 times 5. Okay, so my least common multiple is going to be, start with the lower ones. I got 2 2s. 1, 2. Okay, how many 3s? The most, I've got 2 3s. So I'm picking which has the most. I have on all of them 1 5 and a 7. That's my least common multiple. I just multiply all that out. So I know that this, something times this equals this. Something times this equals this. Something times this equals this. And that's the least common multiple that you can have. Okay? And that's lesson number 20. Okay, and we'll get back to those when we do some more fractions. It's kind of helpful. All right, lesson number 20. Let's get a new page here. And this one is talking about averages. And you may or may not know averages, but I shall explain it to you. If I said, okay, I was in a race, and I got 8th place, one race, and I got 3rd place, and I got 1st place. What was my average? This is how you do averages. You just take your numbers and you add them, and then you divide it by how many numbers? 1, 2, 3. Answer. So in this case, 8 plus 3 is 11, plus 1 is 12. Divided by 3, it's 12 divided by 3, 4. I averaged 4th place. Now, I never actually got 4th place, but my average was 4th place. Average just means you take all the numbers you have, add them together, and then divide them by how many numbers you have. That's all average is. That's all this lesson is do it. Now, if you have decimals, that's why you use calculators. So let's say, for example, practice problem A. This is practice problem A on the lesson, 74.2. And you have 87.3, and you have 106.5. So, and you say find the average. Well, add them together. 2 plus 3 plus 5 is 10. Carry the 1. 5 plus 7 is 12. Plus 6 is 18. Carry the 1. 8 plus 8 is 16. Here's the 1. 268. Now take 268 divided by 3. 3 times 8 is 24. 28 left. 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27. So 89 with 1 left over. And 3 goes into 10 3 times. That's 9 with 1 left over. And so I end up with a bar. So what is my average of these three numbers? 89.3. Add them up, divide by 3, and that 3 has a bar over it because it goes 0.333333 forever. That's the average, and it's okay to have an average that doesn't come out to an even number. It can come out with a non-repeating number or a repeating number in the decimals. That's it. So I hope you enjoy it. That is lesson number 21.